Hey everybody, today we're doing section 3.4, something called the intermediate value theorem, or abbreviated as the IVT. So, and we're also going to talk about boundedness, but it's a pretty simple synthetic division test that I'm going to show you what it means. And to fill in these words up here, if f of x defines a polynomial with only real coefficients, meaning all these numbers are not i's, and if for real numbers a and b, so I give you two numbers like these two, and if f of a, meaning when you plug in a, and f of b, meaning when you plug in b, if they are opposite signs, think about what that means for a second, opposite signs meaning one of them's negative, one of them's positive, then that means there has to be at least one real zero in between them. Okay, so here is what the test is. It's just synthetic division, kind of like what we've been doing for the whole previous chapter to this one. What I'm going to do first is do 3 in the box, and I'm also going to do 4 in the box. So I'm going to do two different synthetic divisions really quick. Line up the coefficients from all of these. Notice I don't need to fill in any zeros because I have x to the 4th, 3rd, squared, 1st, nothing. So it's going to be 1, 1, negative 14, negative 12, 24. I'm going to go through my synthetic division real quick. Negative 18 times 3, that gives you negative 54, negative 30. Okay, interesting. Negative. Not 0, because remember, if it would be 0, that would mean that 3 actually was a 0. It's asking me if there's a 0 in between 3 and 4, not if they are 0. So that's a difference between last chapter and this chapter. Let's do the 4 as well. 1, 1, negative 14, negative 12, 24. Do the same thing here. Okay, so I've done my synthetic division. This is the kind of work that you're going to need to show for a problem like this. And what you're emphasizing here is that, look, when I plug in negative 3, I get negative 30 in my equation. However, when I plug in 4, I get a positive number, positive 72. Here's what that means on this graph, you guys. Let me refer to what this is talking about, because this is the graph over here on the right. So that means that when I plug in negative 3, my y value way down here is negative 30. That's what I got here. So I have the ordered pair 3, comma, negative 30 is right there. And what happened when I plugged in 4? When I plug in 4, it's way off the graph. It's actually way up here at like 72, way off the graph. And what this is telling us is that the fact that the negative 30 is negative and the 72 is positive, that means when I connect these two, don't I have to go through 0, you guys? Didn't I find a 0 in between 3 and 4 just by connecting them? That means that there is a 0 right here in between 3 and 4. That is the whole point of doing this. So there is a 0 between 3 and 4. Because f of 3 was negative and f of 4 was positive. Cool? It's a really simple synthetic division test. The shortcut to remembering how to do this is that you got to look at the remainders. One of them's got to be negative, one of them's got to be positive. That means when you connect them, it goes through 0. Okay? So let's just do a quick one here to practice. Show, by using synthetic division, that there is a 0 between 0 and 1 on this polynomial. So again, what we're going to do is synthetic division with both of those numbers and show that one of them's negative, one of them's positive. So I'm going to do 0, and I'm also going to do 1. Line up the coefficients. Same coefficients for each of them. Go ahead and go through the synthetic division. And then I'll show you, I'm going to pause, fill it out, and then talk about how to answer the question. Alright, so here's what all the work should look like. I know you know how to do synthetic division, but what I did is I went through and I showed that when I do f of 0, I get 2. And also, it would have also been pretty easy if I would have just plugged the 0 in here, and here, and here, and here, and you still get 2 when you do that. So 0 is a really easy number to plug in. But you could do synthetic division. It's also very easy with 0. So when I plugged in 0, I got 2. When I plugged in 1, I got negative 12. That means that the 2 is positive, the negative 12 is negative. And here's the explanation. There is a 0 in between 0 and 1, because when I did f of 0, I got a positive number. When I did f of 1, I got a negative number. So think about if you were connecting those on a graph, it would have to go through 0. Okay, I'm going to skip around just a little bit. I'll skip that second example because it's the exact same. All you do is you use negative 1 and 1, but do the very same thing. So what I'm going to do is actually skip through this upper and lower bounds visual representation. We're going to talk about that in class tomorrow, but there's a little bit of vocabulary and some wordage down here that we need to talk about real quick, and we're going to fill in some of this. So we're also going to talk about boundedness. I'll give you more of a real-life application of boundedness in class tomorrow, but it's another synthetic division type of test that you're going to be looking for. So just a test that you need to memorize. But something is called an upper bound, and it's just a vocabulary word, if, when you do synthetic division, all of the signs in the bottom row are the same. They have all the same sign. Meaning all positive or all negative. Okay, the smallest value that makes this true is called the least upper bound. Which I abbreviate as LUB. And so think about, we have this thing called an upper bound, which is a vocabulary word, and it is an upper bound if when you do synthetic division, the bottom row has all the same sign. That makes it an upper bound. And there's actually a lot of upper bounds for each polynomial. The smallest one of all of those is the least upper bound. So like common sense-wise and a little bit of English language words here, these kind of make sense to be the smallest one. That would make it the least upper bound. So for lower bounds, it's a really similar type of test. Something is called a lower bound if the signs in the bottom row alternate. Meaning plus, minus, etc. They alternate. And the largest lower bound, the largest number that happens with, because it happens with multiple numbers, the biggest one is called the greatest lower bound. Okay, and I abbreviate that GLB. Okay, these are all negative numbers. Think about lower bounds being negative numbers, lower negative numbers, upper bounds, positive numbers. We're going to talk about how to apply this in real life tomorrow in class, but I just want to show you how to do a couple of these problems, because again, it's very simple. All we have to do is we have to take this lower bound, since this is a negative number, and I'm going to do synthetic division with that for this polynomial, and since it's a negative number, I am checking to see if the signs are alternating in the bottom row when I do synthetic division. Okay, that's it. That's all I'm doing. So synthetic division, I'm going to do -2. Go ahead and plug in the numbers. Go through the synthetic, which you guys are getting super fast at. Let's see here. -7, 14, 13. So notice how these signs go from positive, negative, positive, negative, positive. Signs alternate. That means it is a lower bound. Okay? So let's try no real 0 greater than +2. It's the same kind of thing here, but +2 is a positive number. That means it's an upper bound. And I'm actually like trying to figure this out. That's what I'm trying to answer the question for. And remember when we wrote for upper bounds up here, all the positive numbers, it's an upper bound if they all have the same sign in the bottom row. So that's what I'm looking for this one. So what I'm going to do is the same exact synthetic division, except I'm going to use +2 instead of -2. I'll go through my synthetic division. And notice how all of these have the same sign. They're all positive. This means it is an upper bound. Okay, so just kind of a synthetic division test to help us figure out if something is an upper bound or a lower bound. Talk to you again about what that means tomorrow. Right now I just need you to kind of understand how the test works. So I can skip the second one. This very last example just says find the greatest lower bound and find the least upper bound. So in order to find them when you're not given a number to figure out, it's actually very simple as well. So for the greatest lower bound, since L is lower bound, I'm going to start at -1. And for the upper bounds, I'm going to start at +1 and just work my way up. So here's what it's going to look like. I'm going to start with the lower bound. I'm going to start by plugging in -1, and it's just kind of a guess and check type of thing. I'm going to do synthetic division here. And remember, if it is a lower bound, I'm checking to see if the numbers down here alternate. If they don't alternate, I'm going to scratch it and move on to number 2, to -2. And then try -3, then try -4. And that's going to, since I go in order, it's going to help me find the greatest lower bound of all of them. So here we go. I've got synthetic division ready to go. I'm going to bring down the 5, go -5. This gives me 8. So look, these signs are not alternating, so scratch it. -1 is not the greatest lower bound. I'm going to try -2 now. You could erase, or I'm just going to rewrite it. So I've got 5, bring down the 5, -10, 3. Okay, still not alternating. So I'm going to scratch this, and I'm going to go to -3. And some of you might be able to kind of visualize which answer it's going to be based on how good you are at predicting some synthetic division stuff. -30, -34. Boom! Look, signs are alternating. This means that -3 is the greatest lower bound. And that's how you find it. You have to start with -1 and then work your way up because you're trying to find not just any lower bound, but the greatest one of all. So I also need to find the least upper bound. So I'm going to start with 1 and see if all of those signs are the same in the bottom. Boom. Very first try, all the signs are the exact same down here. So that means that 1 is the least upper bound. Just by vocabulary, you guys. You just kind of have to memorize those rules. But again, we're just doing a lot of synthetic division here, so hopefully not too difficult. I'm going to answer some questions in class tomorrow. Hopefully you got these copied down, and we'll kind of apply why we have these least upper bounds and greatest lower bounds, why we even have them in general. There is a real-life application for it, so stay tuned for that tomorrow. Thanks for watching. Have a good night.